So let's start the build with the power distribution board, and we're going to need this screw and this washer because we're going to put the press nuts into the power distribution board. So here is one of the press nuts. I'm going to push it in with my finger, and then using the washer with the rough side facing outwards and the smooth side facing into the power distribution board so that it doesn't scratch any of it, I'm hand tightening it in. And then I'm going to grab an Allen key and tighten it up. And when that tightens, the press nut has some spikes on it that digs into the power distribution board, and it keeps it there so that when I untighten the screw, it stays in place. So I'm untightening it there, and you can see that the press nut stays in place. And we need to do 4 of those. I'm going to show you another one to see if I can get a better angle of it. So that's the press nut at the back there. Use my Allen key, and as I tighten it up, the press nut presses into the power distribution board and it stays there. And then I unscrew it, and there we go. So I have done 4 of those. The next thing we need to do is add the XT60. So it's connected to its other side of the XT60, and we put this spacing plate on. And the reason that we keep them together is so that they don't come apart when soldering. So now I need to tack that into place underneath with a hot soldering iron. Just making sure that it's in place. So you need a really hot soldering iron. Now, yes, I know my soldering iron is dirty. I know it's not a professional one, but it just works okay. So I'm tacking it down the side here. Making sure that I've got a lot of solder on. And then the idea is that once both of these are tacked in place, we cover the whole lot in solder until it flows over the entire area and we get a good join. Because these XT60 connectors are going to take a beating with our batteries connecting all the time. So I'm tacking the other side now. And it looks messy, but it will work. So now I'm going to heat up the entire area until the whole lot is covered in solder. And we need to make sure that it flows over all the edges so that we have a good join. Now I'm adding more solder and just heating the entire lot up. And then onto the other side. Again, heating the entire area and applying solder until it covers everything up. As mentioned, you do need a hot iron to do this because it's a big area that we are looking at to solder. Can you see that the solder hasn't flowed to the outside? So I'm just applying more until it all flows. The solder will find the outside if we apply enough heat. There you go. And it looks fairly neat now, it's not too bad. Just tidying up the other side as well, applying a bit more solder to make sure that everything is covered. And there we go. So I have sped this bit up. I'm just tinning the rest of the solder pads because it's quite tedious and tedious to watch as well. But all of these solder pads need to be tinned for the build. So the dot is where the plus voltage is going to be onto the frame. And we're going to need 8 screws in total. We've got 4 of these screws here that aren't as long as the other ones, and you'll see in the package that you get which screws to use. And then we've got 4 nuts there and 4 longer screws and 4 screw housings. This is to put the PDB and arms onto the frame. So we take 2 of those slightly shorter screws and put the arm on, and this is the X locking mechanism. This works really well and it's really strong. So I'm going to place that over the top of the press nuts there. Now this first one is quite tricky, but I'm going to grab my Allen key. I'm going to turn it over very carefully and screw that in. Then line that up. And do the same for the rest of the arms. Should be easier now one of them is in. So put the screw through and tighten with an Allen key. And do that for all 4 of those. Next is the slightly longer screws. So you want to put it in those screw housings that are provided and push it through. It can take a bit of effort to thread the needle, but it goes through eventually. So I'm flipping the frame over. And that has to come through all the way to the other side. And then hand tighten these nuts up. I'm going to repeat that for the other 4 arms. Again, just hand tightening for now. Then I'm taking my socket wrench and I'm going to tighten them all up. Next, I'm taking one of the motors and I'm going to cut off some of this wire. You don't really have to measure it, just make sure that there's enough room for the ESC to fit on, around about the middle of the arm. Of course, you need to do this for all 4 of the motors. And then strip the wires. These are nice silicone wires on these motors. So once that is done on all the motors, we can take our screws and screw the motors in. Now I'm only using 2 screws here, and I'm not using thread lock for now. You can use thread lock if you like, but I'm not going to because I plan to take these motors off eventually. Just make sure that your screws are tight if you're not using thread lock. Another good reason to just use 2 screws is if you crash a lot and have to replace motors, there's less screws to undo. So I have sped this up, and I'm screwing all the motors in. Now I'm tinning all of the motor wires to connect to the ESCs. So I have sped this up as well, but I'm going to show you one. This is tinning all of the ESCs. So I'm using a bit of sticky back tape there to keep it in place. You can use blue tack as well. So I'm doing that for all 4 of them. You can see that I'm jumping one of this ESCs, and when you do the jumper, that's going to send this motor combination clockwise. So here I have slowed it down. So this solder pad here, this is for our voltage to the power distribution board. The next one is our telemetry. I'm not using the ground there, we don't need to. So telemetry wire and signal wire, or PWM, and this is the ground to the power distribution board. Then I'm going to solder this jumper together, and as I mentioned, that will send it clockwise with these motors connected straight. So this is going to be for motors 1 and motors 3. And then I'm going to tin up where the motor wires connect and solder. Now I'm using tape because I don't have any blue tack, but you can use blue tack to keep the ESC in place while we solder the motor wires onto the ESCs. So this is motor 1 here at the front. The front is depicted by the holes in the front of the frame where the camera plate sits. So this ESC is jumpered so that it runs clockwise, and I'm soldering in the motors. Getting lots of heat in there so that we have a good join. Now I'm going to cut that tape away. Make sure we've got a good join there, and do the same for the rest of the motors. I'm going to speed that up. Next, I'm measuring a piece of wire. This is 14 gauge wire, but it doesn't need to be 14. It can be 16 or 18. This is just what I have. This is from the wiring loom, the KISS wiring loom that you can buy on the KISS website. I'm stripping those wires. You don't have to do this bit in any particular order. This is motor 3 that I'm doing this on. Just making sure that it fits, and make sure that you've got a bit of slack there. And the same with the negative wire. So I'm tinning those wires now. You need to do that both sides, make sure there's plenty of solder on those wires. And then I'm holding it in place with some pliers and heating it up. We need a really good join here. Do the same with the negative wire. Tin it up again, both sides, and make sure you use plenty of solder. Again, I'm holding it in place with my pliers and letting the solder flow, making sure that I'm not touching any of the components on the ESC. Now that is done, I'm going to solder in the signal wire. I've already cut lengths of this. Just make sure that it can reach the opposite side of the PDB, and we can cut them down later if need to be. So that is the signal wire, and the other one is going to be the telemetry wire to the KISS flight controller. As I mentioned, we don't need to solder a ground wire into the KISS flight controller. Otherwise, we would have too many wires really to deal with, and it's not needed. So that's motor 3 at the back there, and this is motor 4. Again, soldering in the signal wire. These wires are pre-tinned and cut to length, as I mentioned. These are just the wires in the KISS wiring loom that I bought from the Flyduino site. The signal wire again, just bending it into shape so that I can solder it accurately. Applying heat to the whole area, and the solder will just flow. This is motor 2, and this is the signal wire for motor 2. I bridged them there, but you can see that if you just lob the iron on it, they unbridge. And then this is the telemetry wire, or TRX as it's known. And that is all of those done. So now I'm cutting lengths of heat shrink, again provided in the KISS wiring kit. I've cut 4 lengths of those, and that's going to fit over the top of the ESCs. Now, if you don't know your direction at this point regarding the motors, then don't shrink them, but I do, so I can shrink them. So just to be clear, with this setup, motors 1 and motors 3 are jumpered for them to go clockwise, and the non-jumpered ones go counterclockwise. So now I am taking a candle lighter and shrinking the heat shrink. Make sure that you don't hold the flame in one place for too long. And I'm doing that for all of them. And just getting it underneath as well, making sure that it's all nice and tidy. Once all of those are done, I'm using my pliers and applying heat to the power distribution board and the wire, and that is going to solder in our ESCs to the power distribution board. You need to make sure that you don't contact with those nuts that hold the power distribution board in. Applying plenty of heat to get a good soldered join. And now we're taking 4 screws, and this is so they can house the standoffs, and that is where the KISS flight controller is going to sit. So I'm just hand tightening them for now. And doing it for the rest. You have to be careful with these nylon standoffs, as they can break easily. I broke a few, but I had some spares. So I'm now screwing them in with the Allen key. Not too tight, as I say, you can break the thread. And then we can take 2 of the spacers provided, and using some cutters, we can cut off the excess of the standoff. And repeat that for all of them. At this point, I'm going to fit the flight controller to the board, and I am soldering up the boot pin. That needs to be shorted. There's a closer shot there, and that's so that we can load the bootloader software. So now I have shorted the bootloader pins, I can plug the USB into the computer, and we should get a solid green light to show that it is in bootloader mode. Usually you will get a blue light. So now we can go onto the computer. Now I have this installed already. This is virtual COM port drivers. You will need to install this to get the driver working. Secondly, we want to go to this website and download the Diffuse program. And lastly, we want to go onto this RC groups thread and download the RC16 version of the firmware. Now this will get updated and changed, but at this current date and time, this is the latest. So it's worth checking out this RC groups thread for the latest firmware. So if I now go down to the Diffuse app here, just close that down, and if I select choose, I can then navigate to the DFU file and press open, and then I can now press upgrade. Your device is read protected. Would you like to remove read protection? Click yes. Your device was plugged in DFU mode, so it's impossible to make sure this file is correct for this device. Continue, however, yes. Okay, that is done. So we can quit out of there and unplug this, and then I'm going to need to unsolder the bootloader short. Just a dab of the soldering iron on those shorted pins will unshort them, and now if I plug the USB lead into the flight controller, you can see that we get a flashing blue light. And now I'm going to tin the pads that are needed for the PWM and the telemetry wire. So this is for motor 1. I'm going with the telemetry wire first, because it's easiest. Bridge there again, but I just swipe it away. and then the signal wire. So I need to flip the KISS flight controller upside down for PWM2. So I'm just going to tin the pads here. And now I'm taking the signal wire for motor 2, which is the motor at the bottom right. And then the telemetry wire. This is so that we can send the telemetry to the on-screen display. So I'm going to need to flip it back round again, because all of the PWM solder pads are at the back and on the top of the flight controller and underneath. So this is for motor 3 or PWM3. Now you can cut these wires shorter, and I have done that because these are already at the back. You can see there the signal wire has gone shorter. Just so that I get a neat job on the wires. We don't have lots of wires everywhere. So I'm then going to flip it back and again cut these two wires shorter because they're at the back, so they don't need to be as long. And this is for PWM4, and I'm tinning the solder pads for the telemetry and the signal. Again, the telemetry wire is the black wire, and the signal wire is the white. So starting with the signal wire, and then the telemetry wire. Now I'm putting the voltage in and the negative wire into the KISS flight controller. Unfortunately, it's slightly cut off at the top of the picture, so you can't see it very well, but it is marked really clearly. Again, this is the wiring loom in the KISS bundle. So that's the negative cable in. And both of these are going to solder onto that solder pad there that you can see. It's actually the other side. And I think the camera cuts out there as well, but I'll show you where these two solder into. It's going to basically connect to the power distribution board, because the KISS flight controller has a built-in regulator, so we can power it straight off the power distribution board. You can see that the positive and negative both soldered onto the power distribution board at the back, and then that can sit back on the top there. It's looking pretty neat now. At this point, we are going to want to sort out our radio gear. Now, this might not be applicable for the majority of people, but my Taranis is the EU version. Banggood sells the X4RSB in the international version only. The international receiver won't bind with the EU Taranis, so if you have an international version of the Taranis, you can skip this bit. But for the rest of us, we're going to have to install the EU firmware to the X4RSB. You first need to make sure that you have installed OpenTX version 2.1 on the Taranis. I suggest you watch Painless 360's video on how to do that if you haven't already. Then we take the S-port cable that comes with the receiver and jab a pin under the servo connector to swap the red and black wires around. You then need to navigate to Frsky's website and download the X4RSB EU firmware and save it to your computer. Extract the contents of the file and then put your Taranis into bootloader mode by holding the trim buttons inwards while turning it on. Then plug in your Taranis via the USB into the computer and create a folder called firmware. Copy over the FRK file to that folder and unplug the Taranis and turn the Taranis off. Plug the S-port into the X4RSB and then the servo connector into the bottom 3 pins of the Taranis with the red voltage pin at the top. Power on the Taranis and long press the menu button. Page over once and navigate down to the firmware folder we created and then press enter. Scroll down to the FRK file, press enter on it and then press flash external device. The LED will flash on the receiver and the Taranis will write the new firmware to the receiver. We can now continue onto the build as we are going to cut up that S-port wire. Now I'm tinning the pads on the KISS flight controller. These are the telemetry port pads that are going to connect into the receiver. That's the X4RSB receiver. And then here, this is for the servo wire connecting to the receiver for the S-bus, and it also powers the receiver as well. So this is the signal wire. Again, I'm using the servo lead out of the KISS bundle. Make sure that it's long enough to reach the back because that's where our receiver is going to go. This is the positive wire and the negative. I've already tinned that and cut it to length. And then this is the wire that comes with the X4RSB, and I've cut it in half, and this is going to connect into the side of the receiver, and it's also going to send the telemetry to the Taranis, although we're going to have it on the on-screen display anyway, but it's good to have a backup. So this is the 5-volt regulator. It's going to turn the 4S power into 5 volts. You have these little holes here which allows you to connect more than one wire, which is quite nice. This is the positive voltage in. Just soldering that in. And then this is the negative wire. And those wires, again, have been pre-cut and they're going to reach to the power distribution board. And that's going to sit at the back as well with the receiver and the on-screen display. So I'm just going to check here that it reaches before we carry on. Just going to feed that through there, and you can see the other 2 solder pads at the other side. It's a spare one, so I need to connect that up. But we need to twist the wires around because the white dot is the positive voltage. So this is the wire for the VTX. So I've cut that to length, and that is getting soldered into the voltage out. So this is the 5 volts out, and this VTX runs off 6 volts. It says on the specs, but it runs off 5 volts fine. The only problem with that is it doesn't put 5 volts out. So I'm just soldering that up, positive and negative. And just clipping any excess solder off there. And then this is the wire that I'm going to power the on-screen display. There is another way that you can do this without using the regulator, and that is to connect the VTX straight to the power distribution board, and then the 5V out to power the camera and also the on-screen display. But I wanted to make sure I got a clean video signal, and also make sure that there's enough current there and power to power the camera and the on-screen display. So I'm pushing this through the other two holes. Like I say, it's really good that this regulator has the option to put 2 wires on. It's like having 2 solder pads. And then I'm cutting a length of heat shrink. Again, this was provided with the KISS kit. This is slightly wider than the ESC, and that slides over the top there. And then using my candle lighter, I am shrinking it so that it's nice and neat. Next, I'm soldering in the telemetry wires to the KISS flight controller, and these will connect to the on-screen display. This is the TX and RX pin. I'm using a red wire and a black wire here, and you also have to solder a ground underneath as well. These are pre-cut to length and pre-tinned, just so that they reach the back of the quadcopter. So I'm lifting the flight controller up again, and that is just so that I can access the ground there. I've already tinned it, and that is going to solder in underneath, and all of these wires are going to solder onto the micro minim OSD, which we'll see in a bit. And then I've put the flight controller back on. Now I'm feeding the regulator through again. This time I'm going to solder them to those spare solder pads there. You need plenty of heat for this, as they're quite big solder pads. And the same again with the negative. Now I'm taking the wire that comes with the HS1177 camera, and I'm cutting the video wire and the ground wire. You then need to strip those 2 wires, because that is where our on-screen display is going to intersect. You can cut the red wire at this point as well, but I didn't, to keep it together. So this is the most complicated camera module I've ever seen. This is for the HS1177 camera. So you take these 2 plastic parts here and screw them into the back plate using an Allen key. It is complex, this, but it is strong, and I think that's what they were going for. So you've got 2 of those, so I'm screwing those in. And then we've got another screw here, and you've got an O-ring which you have to put over the top, and that is so it sits flush with your camera. So we've got another one of those screws, and the O-ring over the top. And then you need to get your camera and get a normal screwdriver, a Phillips screwdriver, and undo the screws on that. Keep the screws safe. We won't be using them again for this build, but you never know when you might want to use that camera again. So now those are out, we can take this back plate, and that sits over the top of the camera. And those metal screws there screw into where the original screws went. And those O-rings are there to make sure that it sits flush. So just guide the screws in, and then using an Allen key we can tighten them up. Don't tighten them too tight, as they are metal going into plastic again. There's a lot of that in this kit. Okay, so now we take the side plates and you see those holes there? Each one of those holes is 10 degrees, so the first one is 0. So we want to go the fourth hole along if I want 30 degrees. So that's what I'm going with. We take another one of the screws provided, and I'm hand tightening that. And then I'm using the Allen key to tighten it further. Then I'm taking the screw that comes with the HS1177 camera, and then that also screws in the side there. And the idea is that if you want to change the angle of your camera, you undo those screws and move it a notch along. It means that the camera doesn't move while you're in flight, which it sometimes does with the stock mount. So we want to do that with the other side. We want it tight, but not too tight. Again, we've got metal going into plastic. And then the screw for the other side. The most complex camera mount I've seen, but it does work. So next, these are the pins that come with the Micro Minim OSD. I'm just using some household objects here, and that is just so that I can hold the circuit board in place while we solder these pins on. I'm soldering them backwards so that they have quite a small footprint. And I'm just going to solder in the first pin here, just so that it's level. And then after that, I'm going to use some pliers to hold them into place and solder in the rest of these pins. Now I can't quite reach the last one, so I'm going to take it out of this jig. I'm just going to solder the last one. Now you will see that the FTDI adapter fits in with quite a low profile, and then we can plug that into the computer. So at this point, we're going to need to install everything on the Micro Minim OSD. So we'll need to move over to the computer, and you'll need 3 programs. First one is Multi-Wii OSD. So we can go into the 32-bit application and open it up, and this is to install the fonts. Okay. So the first thing that we need to do is go to the COM port that we see. Yours might be different, and connect to it. Then where it says Font Tools, we're going to press Select, and we're going to navigate to the KISS folder. Now this is the KISS OSD that you need to download. That's the second bit of software you need to download. So it says that it's installed the fonts there, and now we need to upload it to the board, and it will count up to the number of fonts there, 256. That takes a while to do. So once that is done, we can close the COM, and we are done with that bit of software. So when we downloaded the KISS OSD file, when you extract it, it comes with this folder here, Max7456. You need to copy that folder, and that needs to go into our third bit of software, which is Arduino. So that goes into your libraries here, and you paste that into there because Arduino is going to call from that folder. So now we can go back to the KISS folder there and open kissosd.ino. And this opens Arduino. Now you need Arduino version 1.05. It needs to be that version. And if you're using a NTSC camera, you need to change that here by putting 2 slashes in and deleting the NTSC slashes and put a hash in it. Now this camera is the PAL version, so this is just to show you what to do if it's an NTSC version. So the board version, we need the Arduino ATmega328. And then the programmer is this one here, the Mark II, and the serial port, for me, it's COM3. Now, I'm going to upload it by pressing the upload button. Of course, this is just a test, and I did go ahead and change that NTSC back to PAL, so you need to make sure that you do that if you're using this camera. So you see there, it says done uploading, and we are now done with the programming of the OSD. And now I'm soldering the rest of the pads that we need. These are the video in and video out pads. So the video wire from the camera and the ground wire from the camera, and then out to the VTX, so it's bypassing it. And these are the voltage in and negative to power the micro minim OSD. So this is the wire from the camera. I've already cut it and tinned it. Now these aren't silicone wires, so you can see that they get quite burnt up. And they're really brittle wires. One of them actually falls off, and I had to resolder that in a bit. You'll see that. So this is out to the VTX. That's the ground. And this is the video. So this is the power out from the regulator to the OSD. This is the ground wire going in. And the positive. So after that, we need to solder those wires in from the KISS flight controller to send the telemetry data. It's the RX and TX. Make sure you get them the right way around, otherwise you won't get the right telemetry. And that's where one of the video wires came out whilst I was messing around. And then this is the ground wire, so the wire that's coming from underneath the KISS flight controller and then onto the micro minim OSD. So this is the positive voltage wire. I've now cut that, and I'm going to solder that onto the voltage in on the micro minim OSD. I'm piggybacking off it to power the camera. And then you can get a pin and take that positive voltage wire out if there's we don't need it. So I've plugged the VTX in here, and now I'm plugging in the camera. And then this side we can just plug in the camera module. And at this point you're going to want to power it up and then get your goggles or monitor or whatever and make sure that you're getting all the right readings. Now that all the necessary wires are connected, we can bind the receiver to the Taranis and set up our model. Mini quads are fairly simple, so this shouldn't be too tasking. I have set the model image to TBS Disco. I have set the mode to D16 and our channel range from 1 to 16. I have set the failsafe mode to Receiver. If we page over to the inputs, I have set channel 5 to switch SG for the flight modes and channel 6 to SF for my arming switch, and then done the same for the output mixer. I have also reversed channel 5 in the output screen so that self-level mode is selected as the default mode when the switch is in its high position. Back to the main screen, and I'm going to press bind on the Taranis, which will cause it to chirp. I'm using a 1-cell 3.7 volt LiPo battery to power the receiver at this point. We need to hold down the failsafe button on the receiver, and we should get some flashing LEDs to say that it is bound. Then I will disconnect the battery from the receiver, and when I reconnect it we should get a green LED on the receiver which confirms that it is bound to the Taranis. Next we want to set the failsafe, so I have set the arm switch on the Taranis in the disarm position and the throttle at 0. We then press the failsafe button until the LED flashes on the receiver, and now when the transmitter loses signal, those values will be restored and the motors will stop and the quad will disarm. Now I am putting on the other standoffs that go on top of the KISS flight controller. There's 4 of those in total. You can hand tighten them, and then this is the plate that goes over the top of the flight controller to protect it. Some people also mount their VTX to this, but I'm not going to be doing that. Then you've got 4 nuts that screw over the top of there. Again, we have got metal going on plastic. I'm using my socket wrench to screw them on, but not too tight. Be very careful doing that. And then I'm cutting the top of the screws off, which are in excess. So I'm taking a length of sticky-sided 3M tape. This is double-sided tape, and this is going to stick down the regulator. So you need to peel back that. It's not as easy as it looks. And then the regulator is going to sit on there nice and snug. So now I'm just going to plug the receiver in. This is the pre-bound receiver, and the fail-safe should already have been set. And that plugs in the bottom there. And then this is the telemetry port. I have fed that underneath that plate there that covers the flight controller. And this is just a little bit of electrical tape to cover the on-screen display up. You can use hot glue or liquid electrical tape on there if you want a more final result. Now I'm feeding the wire through to the camera at the front and plugging the camera in. So now I'm putting the standoffs in. You put the screw underneath and then twist the standoffs. I'm just hand tightening for now. But then these front ones, I'm using a socket wrench, and the flat side of those standoffs have to be completely in line with the camera, otherwise it won't fit in. So I'm pushing that in. And then this is the top plate. Again, we have another press nut that goes in the top there. And again, we use one of those spacers. Don't need to use the washer this time. And twist it in. And then use an Allen key. And the press nut will press into the carbon fiber. It takes a bit of force to do that. So now I'm taking this 90-degree SMA connector and screwing it onto the Immersion 600 VTX, and then pushing that through the hole at the back. I'm then taking my ImmersionRC cloverleaf antenna and screwing that in just to keep it in place, whilst I use a cable tie to put the VTX in place. I don't use that antenna in the end, I use an Aomway antenna. But you can cut off the cable tie and that stays in place nice and snug. And it doesn't move. And now I'm taking the battery plate, which stops the battery from moving around, and I'm cutting these tabs off. Otherwise the camera won't fit at the front. And that just sticks into place. And it takes 24 hours to dry that properly. Now I can remove my antenna and the VTX won't move. Now I'm plugging in the VTX's power and also the camera. Make sure it's the right way. And now I'm feeding through the diversity antenna of the receiver through the top. Now if we press down hard, we need to make sure that those tabs on the camera match up. And I'm temporarily screwing these long screws into the back. And that is just while all the other screws of the top plate get screwed in. We'll be taking those out to install the back plate. So those are the front screws there. Just tighten those up. Again, make sure that the tabs of the camera plate are all in, otherwise it may break. So tightening those two screws up at the front. Those are the longer screws, and then the screws that go in the middle are rounded, and they're actually a different Allen key size. And so I'm just screwing all those in there, and that is the last one of that. And that keeps the top plate in. So I'm just doing some final tightening of all these other screws. Don't over tighten them, but make sure that they're snug. And then we're putting one of those spacers in, and I've removed those back two screws, and then the antenna feeds through there. And this is to protect the antennas and also house the antennas. So we've got a slightly shorter screw that screws in there at the front, and then we've got two more spacers that go in underneath there, and I'm hand tightening those screws. So that's the other spacer there. And then tightening this screw in. Just doing it evenly. And now I'm cutting the antennas to length. And those are going to feed over the top. And they're going to screw in at a nice angle. So there's two holes there. There's one at the top and one at the bottom. And you have to feed it through and push it down until they stick in place. And they're not going to move once they're in place. And you're going to get a nice antenna mount. And then I'm just going to use a cable tie at the back to make sure the receiver doesn't move and cut that off. You might be thinking by this point that there is nothing super simple about the KISS flight controller, and you would be right. That is until we get to the software. You download the KISS GUI as a Chrome app the same as you would CleanFlight. Plug the flight controller's USB into the computer and select the COM port at the top and press connect. We only have two screens to deal with. The settings that we need to change are minimal. UAV type is Quad X as standard, which is what we want for a mini quad. Receiver I want to have set as Frsky S-Bus. Minimum throttle I have set to 1080. Max throttle is set to 2000. Min command is set to 1085. Mid command is set to 1500. And try your mid is set to 1500. Something to take note of is that if you have the min throttle set to 1080, then the PID controller will not be active at idle throttle. In other words, at idle, any stick movement to the pitch, roll, or yaw axis will not have an effect on the quad. We need to select One Shot 125. The preset PID I have selected as the ZMR250, which is also the default PID setting. You can select user presets here if you wish, but for this build the ZMR preset works perfect with no adjustment required. RC rate is your dual rates, so the amount of general throw that you have on the sticks. RC curve is exponential, which allows you to have a lower rate close to the center of the sticks and a more extreme rate the further out from the center you go. Rate relaxes the PID controller as you move your stick away from the center, which allows for smooth flying towards the center of the sticks and fast, accurate flips towards the edge of your sticks. For the aux channel setting, I have auxiliary 1 set to level mode, which is my 3-position SG switch, and then the arm set to auxiliary 2, which is the 2-position SF switch. You only really have two useful modes with the KISS flight controller. Unlike CleanFlight, there is no horizon mode, which I personally find a nice feature to get you into acro, but these days I never use it, so I can see why they have left it out to encourage us to use acro mode and learn it. I like to use level mode for landings and takeoffs just to help me to deal with the extreme angle on the camera. It helps me to get an idea of where level is. LPF stands for low pass filter. Flight controllers don't like unwanted noise coming from the battery, ESCs and FPV gear. An onboard low-pass filter irons out any issues you might be having there, so you can play around with that. I have got mine set to high and it works fine. Once you are done there, you can save the settings. You can also share your preset if you have made any significant PID changes. Onto the Data Output tab, and you can view your PWM inputs to check the direction of the sticks is correct. You also want to put the quad on a level surface and calibrate the accelerometer here. Next, we want to calibrate the ESCs. This is where the KISS FC is lacking in functionality somewhat. On most flight controllers, to calibrate the ESCs, all you have to do is plug the quad in and turn the transmitter on with the throttle in the high position. When the KISS FC boots up, it is disarmed, and therefore it does not send its throttle PWM value to the ESCs. So, as a workaround, you have to plug the quadcopter into the computer first via the USB cable. Set the min PWM value to 2000, which is recognized as the maximum throttle, and then save the settings. You then need to arm the board using the arming switch. Then plug in the flight battery, which sends a 100% PWM value to the ESCs, and the ESCs then recognize that they are in calibration mode. Hit the disarm switch on the Taranis, which tells the ESCs that we are at the minimum throttle. The ESCs are then calibrated. You then need to set your minimum throttle back to 1080 or whatever preference you had and save the settings again. It's not super simple, I think you will agree. I have added a couple of more things which are self-explanatory, but I'll go through them anyway. The GoPro 3D printed mount, cable ties on here, which is the HS1177's mount. I have added a rubber cover for the GoPro so that when it gets smashed up, it doesn't break the GoPro, and the same for the lens protector here. It stops the lens from cracking in a bad crash. I have added these purple nuts here, which are for the propellers, and all of the propellers are on. I've switched out the antenna for an Aomway antenna. I just find this works a little bit better than the ImmersionRC antenna. And of course the Rotogeets battery strap there. So there you go, that is my build video of my Alien 5-inch mini quad. I hope you enjoyed it and found it useful. You can subscribe to me on Instagram at AndyRC_channel, where I'll be posting more pictures of upcoming items on the channel. Thanks so much for watching. Please continue to subscribe. Cheers.
Tornado.